Welcome back to Precalculus, section 4.5. I just made up a pretty exciting problem, so this is one I made up on the spot, so hope you follow along. Y equals -2 sine of pi over 4 theta minus pi over 2 minus 1. So we have everything going on. An amplitude that's negative, even, a B, a C, and even a D. So let's see what happens. First of all, our amplitude, let's change colors. That'll make it more exciting here. Our amplitude, hang on here. Whoops. Okay. Our amplitude is 2. It's the absolute value of A, but it's going to be negative. So let's put a little star there to remind us to start low. Keep trying to squeeze everything in up here, which makes my handwriting that much worse. Sorry about that. We're going to shift down, so I'm just going to write down 1, and that's actually going to make our period normally would our range would normally be -2 to 2, but since it's down 1, it's going to be -3 to 1. So that's going to be our new range. Let's just write that in there. Let's see what else. Now we got to take care of this part in here. First, let's do the period. The period of this is 2 pi over b, and b is pi over 4. Sounds terrible, but it's actually pretty good. You're multiplying by the reciprocal, which is 4 over pi. The pi's cancel, and you get 8, which is actually pretty good, because the critical distance is always a quarter of that, and a quarter of 8, this stylus is really hard to write with, let me tell you, is 2. So that's pretty good. That'll be easy to work with. No pi's, no fractions, none of that. I guess. Our final thing is we want to find out where we start, and this is usually the thing that could be the most trouble. So set the thing in parentheses equal to 0, because when it equals 0, when you're signing an angle of 0, we know we're at 0. That's where sine starts. So when we set it equals 0 and solve it, we can find out where to start. Half pi over quarter pi is 2. If you have a half pi and you're going to split it into 2 quarter pieces of pi, that's 2 pieces. So this is what I'm calling our start. I'm going to kind of mark the key stuff here so we don't forget about it. I think this is the key stuff. The range, this starting down thing is important. The period is important, of course, and I'll probably... Okay, I tried winding back. It didn't like it. I don't know why, but sorry about the delay. Okay, so our range is -3 to 1. That means we need to have the majority of what we see be below the x-axis. Let's just go ahead and mark that out. 1, 2, 3. Yeah, that's right. Okay, so let's do this whole thing again. I'm going to go out 2 periods to 16, and you might wonder, should I go to 18? But I want to show it across the x-axis, so I'm only going to go to 16, and you'll see how I do this in a second. Now, in case you missed my comment before, I do want to say that the purple is in honor of K-State's stunning victory last night. Oh, yes. Okay, what are we doing now? So the start is at 2. Where is that? Starts at 2. So I'm going to go to 2, and since I'm going down 1, I'm going to go down 1. Ooh, let's get my dots. Let's see if I can do that here. Pink dots. Okay, the pink is in honor of Kate. Oh, I don't know who's in it. We're just going to do pink. just 'cause I haven't used it yet. So at 2, we're going to start down 1 at our equilibrium position, which is -1, because we're going down 1, as you see. We have a star. That means we have to go in the opposite direction, so we're going to move downward first to our minimum, which we said is -3. And once you get those first 2 points, it just flows really nicely. Then the next point's the equilibrium, maximum, equilibrium, minimum, equilibrium, maximum. If you back up 1, which is what I'm proposing, it's going to go from equilibrium to maximum. So you can see we have 2 full periods because it goes from a max to a max. Doesn't look like your traditional sine because it actually looks like a cosine, doesn't it? That's okay. That's what happens when you start shifting it around in so many different ways. But this is the curve. Now what you could start doing now is thinking, this is actually a cosine shifted down 1. You wouldn't have to do any phase shift. And that's true, you could. But we're just graphing what they give us. So hopefully this is right, and this is helpful for you. So I'll see you in class next time. Thanks for watching.
Made with Doodlecast Pro.